All right, guys. So in our first three sections, we've looked at both how to simplify as well as our four main operations of multiplying, dividing, adding, and subtracting. That now sets us up to where we should be ready to begin solving rational equations. And then once we've solved, that should lead us to being able to graph rational equations as well. So to solve, let's just start by talking about some general tips and some general suggestions for solving rational equations. Number one, make sure that you always state your domain restrictions. So set your denominators not equal to 0 and solve, and that way you know what values of x won't work. Number two, make sure to always check your solutions. Sometimes, but not always, you'll get a solution which is also part of your domain restriction. And if x can equal 2, but you get a solution of x equals 2, then clearly that's not going to work in the original equation. It's not that you did anything wrong, it's just an answer that doesn't work. And when that happens, we need to label that as what's called an extraneous solution. Number three, whenever you end up with a quadratic, make sure that you always try to solve by factoring, and if you can't factor, then use some other method. Finally, if it's linear, then obviously you can just solve that linear expression for x. Those are usually pretty easy. We're going to look at basically three different scenarios, starting with the easiest and working our way to the more difficult. So the first scenario is if the denominators on both sides of the equal sign are the same. When that happens, if your denominators are the same on both sides, then all you have to do is set the numerators equal as well and solve. Now, why is that? Think about fractions, and let's go back and maybe think about a very simple equation like if you had 3 over 4 equals x over 4. If that were the case, then our denominators are equal, then you could just look at your numerators and say that 3 equals x. Pretty easy stuff. In fact, it should be pretty easy for rationals as well. Let's start by taking a look at number one. Now, before we get into any solving, let's go ahead and state our domain restrictions. In this case, our domain restriction is that x cannot equal -3 because that would make our denominator equal 0 on either side of the equation. Now, because you've got x plus 3 as our denominator, we can go ahead and just set our numerators equal to 0, or set them equal to each other, rather. So 2x plus 5 is equal to x minus 7. Really what you're doing, for those that are curious, is you're actually multiplying by a factor of x plus 3 on both sides of the equation, and then that's what allows you to set your numerators equal to one another. Now, solving that equation, let's go ahead and get all of our variables to the same side. So we'll subtract x from the right side. So that'll be that x plus 5 is equal to -7. And then subtract over your 5. So x is going to be equal to -12. Now, the only problem we had was that x couldn't equal -3. Fortunately, that wasn't our solution, so we're good to go ahead and move on. So let's take a look at number two. Very similar idea in number two. Let's start by stating our domain restriction, which in this case is that x cannot equal 4, otherwise our denominators would equal 0. Now, you can either go straight to setting the numerators equal to each other, or if you wanted to show an extra step in here, you could show multiplying by x minus 4 on both sides of the equation, which then once again allows us to set 2x minus 5 equal to 11. From there, we just solve like we normally would. So we add over the 5 and get that 2x is equal to 16, and then divide by 2 to come up with x being equal to 8. Once again, we'll check that with our domain restriction. The only restriction we had was that x could not equal 4, and in this case, since it equals 8, then we are good to go. Our next special type of equation is when the denominators are not equal, but the equation is still a proportion, meaning you've got one fraction equal to a second fraction. Then we're going to solve by cross multiplying. And again, I'll show you kind of how that works. Let's first just look at it for an example with some more basic fractions. So if you had two fractions, denominators that were different, but we know the ratio is the same, in other words, something like 3 over 4 equals x over 8, then we can solve by cross multiplying and say that 4 multiplied by x has to equal 3 multiplied by 8. And then from there, you just solve, divide by 4, to come up with x being equal to 6. So let's see how this would work for some rational equations as well. So for our first equation, we've got x plus 3 over x minus 1 being equal to x plus 2 over x minus 3. Let's start by stating our domain restriction, which is that x cannot equal 1 and x cannot equal 3. Notice that our denominators in this case would become 0 if either of those were to be the case. Now, we're going to end up cross multiplying, meaning that we're going to take x minus 1 multiplied by x plus 2 and taking x plus 3 multiplied by x minus 3. Truthfully, what we're doing, if you want to think about it this way, is we're actually finding a common denominator, meaning that on the left side of the equation, we're multiplying by the missing factor of x minus 3, and on the right side of the equation, we're multiplying by our missing factor of x minus 1. Notice that when you do that, your denominator now becomes the same, and just like we did in our examples on numbers 1 and 2, we can then focus on our numerators, which notice does the exact same thing as cross multiplying. You're taking x plus 3, multiplying by x minus 3, and x plus 2 and multiplying by x minus 1. So again, you don't need to show all of that work. You really just need to be able to show the cross multiplication of taking x minus 1 multiplied by x minus 2 and setting that equal to x plus 3 multiplied by x minus 3. From there, we'll go ahead and distribute our terms. So on the left side, we'll get x multiplied by x is x squared. X multiplied by negative 2 is a minus 2x. And then continuing to distribute, we're going to have a negative 1x and a positive 2. Then we'll go ahead and combine our two middle terms together. So that's going to be minus 3x plus 2. And there's our left side of our equation. For the right side of the equation, we'll do the same thing. So distributing, we'll get x squared minus 3x plus 3x minus 9. And in a similar way, we'll combine our two middle terms. In this case, they end up adding to be 0, and that means that our right side of the equation is now going to be x squared minus 9. Now, to solve from here, since we do have a quadratic equation, remember you do need to get one side of the equation to equal 0, so I will do that by subtracting the x squared, adding the 9 from our left side. That way the left side of the equation is equal to 0, and then we can focus on the right side. As for the right side of the equation, x squared minus x squared is also 0, so we actually end up with not a quadratic equation, but a linear equation when we're done simplifying. From there, we'll go ahead and solve like we normally would, so subtract over the 11, and then divide by the negative 3. That's going to give us our solution, which is a fraction, x equals 11 thirds. All right, let's do something similar with number 4. And I won't show all of the extra steps this time. We'll just go straight to the cross multiplication. So we'll take x multiplied by x plus minus 4 and set that equal to x minus 6 multiplied by 1. So as we go to solve, for our left side of the equation, distribute the x, that would become x squared minus 4x is equal to, for our right side of the equation, x minus 6 multiplied by 1 is just x minus 6. So just like we did with number 3, since we do currently have a quadratic equation, let's go ahead and get one side of the equation to equal 0. I'll do that by subtracting x and adding 6 on both sides of the equation. That way the right side of the equation is now 0. For the left side, x squared, and then negative 4x plus negative 1x, negative 5x, and 6 plus nothing is 6. So now we're going to look to solve this quadratic equation. We should probably first check to see if it is factorable, meaning let's look for some numbers that would multiply to be 6 and also add to be negative 5. And those two numbers are going to be negative 2 and negative 3. So we'll have x minus 2 multiplied by x minus 3 is equal to 0. And now we'll use zero product property to say that x equals 2 and that x equals 3. Now I missed a step at the very beginning, and if you caught me on that, nice work. I did not state our domain restriction just yet. For our domain restriction, we would have said that x cannot equal 6 and x cannot equal 4. That is important because we need to make sure that our solutions are not 6 or 4, and in this case, we are good since they are equal to 2 and equal to 3. All right, now we're into some of the tougher questions. So, what do we do if the denominators are not the same and there's more than just the one fraction equal to the other? In other words, what happens when there's addition or subtraction that's involved? And if that's the case, if there is addition or subtraction, you must get a common denominator. And then once you've got a common denominator, then you just solve the numerators like we did on numbers 1 and 2. Remember that once you have a common denominator, then the numerators must be equal to 0. As an example with fractions, here's a good chance to look at kind of how this works. If you've got 3 over 4 plus x over 2 being equal to 7 over 4, then our common denominator in this case would be the number 4, meaning we'd have to multiply our second fraction by 2 over 2. That now gives us the equation 3 over 4 plus 2x over 4 is equal to 7 over 4. And since everything is over 4, we can get rid of our denominator, focus on our numerator, and say 3 plus 2x is equal to 7, and then solve that like we normally would to get that x is equal to 2. So let's see how we can apply that to working with rational equations as well. So taking a look at number 5, we've got 3 over x plus 2 plus 12 over x squared minus 4 being equal to negative 1 over x minus 2. So notice that right now we do not have a common denominator. In fact, we also have some factoring that needs to take place. Notice that x squared minus 4 is a difference of squares. It factors to be x plus 2 and x minus 2. If you remember from the previous video, if you're ever stuck trying to factor, most of the time math teachers, including myself, like problems that work out. And so if you're stuck, you might try using the factors for your other two denominators to see if they would work to factor your other quadratic. And in this case, they actually do. So looking for a common denominator, it looks like our least common denominator is going to need to include x plus 2 as well as x minus 2. In fact, x plus 2 is a factor for our first two fractions. We also need for that to be a factor for our third fraction as well. Make sure that you're multiplying by that in both numerator and denominator. Also, notice that x minus 2 was a factor for our second two fractions. It also needs to be a factor for our first fraction as well. Again, make sure that you're multiplying by that in both numerator and denominator. Now, before we get any further, let's go ahead and state our domain restriction while we've got everything still in our denominator. So our domain restriction is going to have to be that x cannot equal 2 and that x cannot equal negative 2 because of our factors of x plus 2 and x minus 2 in our denominator. Now, taking a look at our equation, you'll notice that we actually have a common denominator now. Everything is over x plus 2 and x minus 2. And when that's the case, remember that once your denominator is the same, you can just focus on the numerator. In fact, you can get rid of the denominator altogether. And so then let's go ahead and write what we've got at this point for our equation. We've got 3 multiplied by x minus 2 plus 12 is equal to negative 1 multiplied by x plus 2. So let's go ahead and distribute first. So we'll get 3 multiplied by x is 3x. 3 multiplied by -2 is -6, plus 12 is equal to, and distribute the -1 now, so that would be -x minus 2. All right, so now let's work at solving this. Let's go ahead and combine our like terms on the left side. So 3x plus 6 is equal to -x minus 2. Now we can get all of our variables to the same side, so add over the x is 4x plus 6, which is equal to -2. Now we'll go ahead and subtract over the 6, so 4x is equal to -8. And now divide both sides by 4, and we'll get that x is equal to -2. But before we go any further, we have a problem, because we said earlier for our domain restriction that x cannot equal -2. That would be a problem, because then our denominator would equal -2, or would equal 0. And that's a problem. We don't want our denominator to equal 0. So -2 cannot be a solution. In fact, what we're going to do is we are going to cross it off, and we're going to call it an extraneous solution, which I'll abbreviate right here, EXTSOL, which again is an abbreviation for an extraneous solution, which is something we talked about in the beginning of the video. What that means is not that we did anything wrong. In fact, we did all of our solving correctly. It just means that the solution we got just doesn't work in the original equation. And actually, since that was the only solution that we got, what we're going to have to say instead is that there is no solution to this equation. All right, let's take a look at one last example, and then we'll be done with this section. So number 6, very similar setup. We've got our denominators, which we need to get to be the same. We also do have some factoring that we need to do. We need to factor x squared minus 5x plus 6 by finding numbers that multiply to be 6 and add to be -5. As a clue, you might try using your other two factors. And in fact, -2 and -3 do in fact work for our factors. So now, trying to get a common denominator, notice that you have x minus 2 in both your first and your third fractions. That means you also need to have x minus 2 in your second fraction as well. Also, notice that you have x minus 3 in each of the second two fractions. That also means you need x minus 3 as part of your first fraction as well. Now, taking a look, it does look like our denominators are all in fact the same now, but before we cancel those out, let's real quick go ahead and state our domain restriction, which is going to be that x cannot equal positive 3 and that x cannot equal positive 2. Okay, so now that we've done that, noticing that our denominators are the same throughout our entire equation, we can now get rid of our denominators and focus just on the numerators. Which, our numerators, it looks like we've got x multiplied by x minus 3 plus x multiplied by x minus 2 is equal to our right side of the equation, which is just the number 3. All right, so now simplifying, let's go ahead and do that real quick here. We're going to take x multiplied by x is x squared. X multiplied by -3 is a -3x. Then we've got x multiplied by x is x squared. X multiplied by -2 is a -2x. All of that still equal to 3. So now let's go ahead and combine some like terms on our left side of the equation. X squared plus x squared is 2x squared. -3x plus -2x is -5x. All of that still equal to positive 3. Notice that this is still a quadratic equation, so we need to get it equal to 0. Let's go ahead and just subtract the 3 from our right side of the equation to now have our equation 2x squared minus 5x minus 3 being equal to 0. So let's first try to solve by factoring. If you don't want to solve by factoring and want to go to completing the square, probably wouldn't recommend it. I suppose quadratic formula would work if you wanted to try to use it, but I think factoring is going to be quite a bit easier. Remember to factor when there's a number in front of x squared. We're going to start by taking that value multiplied by our constant. So 2 multiplied by -3 is -6. That will be the top part of our diamond, and then we'll use -5 as the bottom part. So we now need numbers that multiply to be -6, add to be -5. Those two numbers are going to be -6 and +1. Now, don't forget about that number that's in front of x squared. That 2 needs to be put above each of those values, and we now need to simplify if at all possible. On the left side, both of our numbers are divisible by 2. 2 divided by 2 is 1. -6 divided by 2 is -3. For our right side of the equation, both 2 and 1 are not going to be able to simplify. So using our numbers to write our factors, we're going to have 1x minus 3 from our left side of the diamond, and then 2x plus 1 from the right side is equal to 0. We'll now use zero product property to set each of those equal to 0 and solve. For the first, we'll get x equals 3. For the second, we'll get that x is equal to -1/2. Now, checking both of those solutions that we've got, one of them is not going to work because remember, for our domain restriction, we said that x cannot equal 3, and here we had x equals 3. We're going to cross that off and call it an extraneous solution. However, there was no problem with -1/2. We just couldn't have x equal to +2, but that means that we do actually have a solution. So unlike on number 5, where our only solution was extraneous, on number 6, because one of them was extraneous but the other was not, we still have this -1/2 as a solution. All right, guys, so that about does it for solving. That hopefully gives you an idea of what we'll be doing in order to find our x-intercepts for graphing later on in the next section. Until then, have a great rest of your day.